Okay, we're going to solve this system of equations with elimination. And this is a harder example of using elimination because if we look here, we don't have any variables that are the same. We have a 2 and a 5 and a 3 and a 9. What we have to do is manipulate one of these equations so that the variables line up with each other, that they're equal to each other. So if I look at our x's, are 2 and a 5, I can multiply 2 to get 5 by 2.5, but that's a little bit messy because I'm using a decimal. If I look at over here, to go from 3 to 9, well I just need to multiply by 3. And that's much easier, so let's do that. So what we do is we take our whole equation and we multiply each thing by what we need to get to our other variable. So in this case, to get to 3 to 9, we need to multiply times 3. So 2x times 3, 3y times 3, and 1 times 3, which will give us 6x plus 9y equals 1 times 3 is 3. And now we can solve this just like any other system, and I can make a new system here, and we subtract. So 5x minus 6x is negative x. 9 minus 9y is 0. Good, we've canceled out a variable there. Negative 2 minus 3 is a negative 5. Negative 5, it's not a decimal. Negative 5. And then I have negative x equals negative 5. I'm going to divide both sides by negative 1. So x equals 5. And now I need to take this and plug it in to either equation. I'm going to plug it in the top one. The numbers are a little bit smaller. So 2 times 5 plus 3y equals 1. 10 plus 3y equals 1. Minus 10 for both sides. 3y equals 1 minus 10 is negative 9. Divide both sides by 3. Y equals negative 3. Now these should both work in here, so let's try it. 2 times 5 plus 3 times our y value of negative 3 equals 1. 2 times 5 is 10. Minus 9, because 3 times negative 3 is going to be negative 9, equals 1. 1 equals 1. And our equation works, so our answer that we're going to have is 5, negative 3 as an ordered pair.